Hi, Evan. I've got those questions here that you're asking about, so I'll try to explain them. Starting with question 5, a gas station has a 7% chance of running out of gas. So starting with the first part of the question, what is the probability that the gas station will run out of gas one day in the next week? So 1 out of the 7. And so if we do this as if we approach this as a binomial distribution, then they're just asking us, out of 7 days, what's the probability of exactly one day? And so that's 7 choose 1. The probability of running out of gas is 7%, so that's 0.07. We want that to happen once, and then the Q value is going to be 0.93, and we want that to happen on the other 6 days. So that's the probability of exactly one day out of 7 for it to run out of gas, okay? If we look at B, sorry, this is kind of messy. B says what's the probability that the gas station will run out of gas at least 2 days. So that changes things a little bit, okay? At least 2 days means 2, 3, 4, 5, 6, or 7, and that's a lot of work. So we already done 1 in the first part of the question. In part A, we already found the probability of it running out of gas for 1 day. So if we find the probability of 0 days, we add that to the probability of the 1 day that we found in part A, and then we find the probability, it says at least 2 days. So sorry, we don't need another probability there. Then what we're going to do is do this one sort of the backwards way. If we find out the probability of it being less than 2 days, then we'll just subtract that from 1, and that will give us a probability of at least 2 days. And so when you structure that one, you would do 7 choose 0, and this to the 0, 0.93 to the 7, plus 7 choose 1. Oh, we already did that one, P1. That was the one from above, sorry. So we've already worked that out. You can just put it in there. Whatever that equals, the probability that x is at least 2, which means greater than or equal to 2, is going to be 1 minus whatever you got in the line above. That's the easiest way to handle it when it asks for at least, okay? So for part C, what is the expected number of times that the gas station will run out of gas? If it's 7% chance of it running out of gas, then we have 7 days. So if we use the NPEX as expected value equals NP, we have 7 days and a probability of 0.07 of running out of gas. And so that's going to give us a probability of 0.49, or not a probability, sorry, our expected value of 0.49 days out of the 7, or half a day out of the 7. And I know that doesn't really make sense because you can only have a full day, not a half a day, but that's how it works out in terms of the expected value for that question. So I'm going to go over to question 6 on the next page and have a look at 6D with you. I'm just going to try and change pages here, and I hope it works. Hang on a minute. All right, it looks like it worked. Yay. So I've got question 6D here, and I cut it off a little bit because I couldn't get the whole screen capture to show up when I took the picture. So the first part that I cut off is that the cruise ship has a 74% chance of having leftover rooms the week before the cruise. There are 25 cruise ships setting sail this month. So you had asked about 6D, And 6D refers back to 6C, where they were asking about exactly 20 cruise ships having leftover rooms. So instead of using the normal approximation, if we use the binomial distribution value instead, then we're going to set that up exactly the way you have it down here. That's correct. Exactly 20 days would be a point. Now let me see. Exactly 20 cruise ships will have leftover rooms. Is not the probability of having a leftover room, isn't it 74%? I think it is. Yeah. So I think what you want to do is reverse these, okay? Because exactly 20 cruise ships having a leftover room, the chance of having a leftover room, sorry, I can't see the green there, is 74%. You want 20 of them to be that, and you want the chance of not having a leftover room to only be applicable to 5 of those cruise ships. And so if you just switch those two values around, then you're right on the right track in terms of using the binomial distribution to find the value. And then all you need to do is compare it to the normal approximation that you got in Part C. So I hope that helps, and I certainly don't mind helping you out on these review questions or practice exam questions if you want to do exactly what you're doing and send me the work, and I can see what you're doing, and I can make you a video to help explain it and get you going on them, okay?